Hi everyone, we are Team 1. Today, we're going to analyze the data provided by our customer, which is a house remodeling company, to predict the most significant factors influencing the house sales price. We will analyze why these factors have such great impact on house sales price in a scientific and interesting way, sector by sector. So here is the introduction of background. After years of price appreciation, the housing market might change radically. Our task is to understand historical house price data and to describe and interpret historical sales in order to predict the future market. So, what are we analyzing? We need to summarize the data set. The data set is presented in the form of the spreadsheet. We got 1,416 rows and 81 columns. Each row of the data set represents a house sold, and each column represents a specific characteristics of the house. Then, when you think about target variables, we're going to focus on the 6 variables in the right side, and we believe all the variables will cause effect to the sales price. The first one is overall quota, which means the overall material and finish quality of the house. The second variable is the total square feet of the basement area. The third one is year remote end, which means the remote date. The year build, which means the original construction date. And the fifth one, which means square footage of living space above the ground. And the final variable, which means size of garage in car capacity. We're trying to explain the relationship between this variable and sales price with the most understandable linear regression model. Our purpose is to determine whether the selected variables has a linear relationship with sales price.
Hi, I'm Sissy. There are a few steps of preparation before we build the model. Let's have a look together. To predict the sales price, it is good to have a broad pictures of these target variables. Therefore, a histogram is used to show the distribution of the sales price. The graph shows a mean of 180K, while the median is 163K. It is right-screwed with a long tails on the right-hand side. This might be due to the outliers in the long tails as they will drag the mean upward. The right screw implies that most houses were sold at the price below average. The mood of 150K indicates that most houses are sold around that mood. Now let's move on to the correlation part. There are 28 numeric variables. We have picked 8 highly related variables from the group based on the correlation test. To understand the importance of these variables related to sales price, a heat map is performed. In Figure 2, red represents perfect positive correlation, and white represents the perfect negative correlation. Since we are only interested in the relationship between the sales price and the 8 variables, only the first column is relevant. There is no negative correlation in this heat map. This is because a component in a house will not decrease the house price in reality. As the shade of the square on the graph darkens, the variable will be more positively correlated with the sales price. For example, in the first column, the overall quality is the darkest square, while the year built is the lightest square. This means overall quality will affect the sales price more than year built. So, when predicting the sales price, we should be more concerned about the overall quality rather than the year built.
Before running a linear model, some assumptions must first be met. The first of which is that the residuals, meaning the difference between the observed values and the values predicted by our model, should be nearly normal. That is shown to be satisfied in this first graph. Another check which must be met is that our data shows homoscedasticity, meaning the scatter of our observations around our regression line should not differ significantly as we progress along the x-axis. The data shows this to be near enough the case, as the square root of the residuals are predominantly flat when plotted against the predicted or the fitted values. A third necessary check before running our linear model is that none of the independent variables are highly correlated with each other, or in other words, are collinear. We want to examine the effects of each of our independent variables on sales price individually, with all else held equal. This becomes very difficult to do if two or more variables are correlated, since they'll tend to move together jointly. The third graph shows that in our variables chosen for the final model, none are collinear, as evidenced by their VIF scores falling in the 2 and 3 range. They would need a VIF score of around 10 to be considered collinear. Now that our linearity assumptions are met, let's take a look at the results of the model. The first thing to note in the output is that every variable used in the model has a significant p-value. This means that the addition of each variable causes our model to predict more of the variance in sales price than it would otherwise with the pre-existing variables. Next, let's examine the estimates. The slope estimates simply estimate how much the sales price will vary per unit increase of each associated variable. The final output is the R-squared value. The value our model returned of 82.5% indicates that this much of the variability in sales price can be explained by our chosen variables. Considering that pricing has a human behavior component, this is a very high value. Studies attempting to predict human behavior tend to have a value of around 50% or below. I'll now pass on to Safraz to provide some further explanation about these results.
Now, with the performance of the model chosen, the variables like the overall quality and the year built contribute to the sales price. This then comes back to our hypotheses, where we have said that the higher the quality of the materials used means that the house price increases. And this is also true for materials used as well, as the higher the materials used, the more expensive it is, and vice versa, the cheaper the materials, the cheaper the home is. Now, I'd like to quickly take a look at the code and what this means to our hypothesis. Our code used a basic model of the code that used all the variables, and this goes back to our initial idea that we chose that all these variables impact the sales price. With the results, this covered 82% of the population. With our initial model, this only covered 77%. However, once the outlier was removed, this covered 82%. This means our model is covering a majority of the population, which is good when we look at house prices in this example. Our code also found that between the variables themselves, there was a high correlation between the basement area and the basement garage space. This makes sense, as when we look at the basement space, this just means that the sales price is influenced, as the more area there is, the more the price increases. Next, I would like to quickly touch on numeric values. As we go back to house price, the higher the values went, the higher the sale price went. This is because the numeric values build up the value of the home, so the number goes up higher. What this tells us, the house prices are dependent on these variables from our model, as you can see between the correlation between the house prices. As one increases, the other decreases.
Thank you, everyone. The 6 explanatory variables that influence the house price in our model will help us make prediction. Our initial hypothesis was that the house setup and condition should impact how much people are willing to pay for. The bigger the space of the functional area inside of the house and the better quality of the house means higher sale price. What comes surprising is that the bedroom size and lot area was not as influential as the other variables we have looked at. As we all know, the land value is a crucial factor when purchasing a property. Now let's look at a quick example. House A with an overall quality rating of 7, 2 garage car space that has been recently renovated in 2003. The estimated house price will be $213,000 based on our model. For a business, we can potentially use this model to calculate an estimated benchmark for auctioning or negotiating the price of the house and understand whether the price is reasonable or not. Finally, after going through the exercise of building our model, we believe that there are more ways to enhance our model and get more confidence in predicting house prices that is closer to reality. For example, outliners will need to be further investigated, and we need to be more aware of the unusual cases where some houses are selling for an extremely low price because a renovation is required. we will need to take into considerations of reality when we are analyzing. Furthermore, we believe that there may be a nonlinear relationship between the explanatory variables and sale prices that we can explore more by using other models such as logarithm model or projected models to improve the model accuracy and bring our prediction closer to reality. Thank you for listening.